Dear students, today we are going to do question number 3 of exercise 2.4. The question is like this: find the value of k if x minus 1 is a factor of each of the following cases. First part is p of x is equal to x square plus x plus k. Second part is px is equal to x square plus kx plus under root 2, and the third part is px is equal to kx square minus root 2x plus 1, and the fourth part is kx square minus 3x plus k. Solution. First part, since we are given px is equal to x square plus x plus k, by factor theorem you know that when x minus a is a factor of px, then p of a should be equal to 0. Here x minus 1 is the factor of px, which implies the 0 of x minus 1 or of this linear polynomial is x is equal to 1. So here we must be having p of 1 should be equal to 0. px is equal to x square plus x plus k. Since x minus 1 is a factor of px, therefore p of 1 should be equal to 0, which implies in place of x we have to substitute the value 1, which implies 1 square plus 1 since x square plus x plus k is equal to 0, which implies 1 square plus 1 plus k should be equal to 0, which implies 1 plus 1 plus k is equal to 0, implying 1 plus 1 is 2 plus k is equal to 0. Here on the left hand side the sign of 2 is positive. When we transfer it to the right hand side, the sign will get changed, therefore k is equal to minus 2 is its answer, because we have to find the value of k. The second part is p of x is equal to 2x square plus kx plus square root of 2. Since x minus 1 is the factor of px, since x minus 1 is the factor of px, therefore by factor theorem p of 1 should be equal to 0, which implies since px is equal to this polynomial, in place of 1 we have to, in place of x we have to substitute x is equal to 1, implying 2 into 1 square plus k into 1 plus under root 2 is equal to 0, which implies 1 into 1 is 1, it implies 2 into 1 plus k into 1 is k plus root 2 is equal to 0, which implies 2 into 1 is 2 plus k plus root 2 is equal to 0. Here the signs of 2 and root 2 on the left hand side is positive. When we transfer it to the right hand side, the sign will get changed, therefore k will be equal to minus 2 minus root 2. Third part, px is equal to kx square minus root 2x plus 1. We are given x minus 1 to be the factor of this polynomial, therefore by factor theorem p of 1 should be equal to 0, and x is equal to 1 is the 0 of x minus 1. since x minus 1 is the factor of px, therefore p of 1 should be equal to 0, which implies k into 1 square minus root 2 into 1 plus 1 is equal to 0, implying k into 1 square is 1, it is k, minus root 2 into 1 is root 2, plus 1 is equal to 0. Here the sign of root 2 is minus. When we transfer it to the right hand side, sign will get changed and it will become plus. Therefore k will be equal to root 2. Here it is plus 1. When we transfer it to the right hand side, it will become minus 1. So k is equal to root 2 minus 1 will be its answer. And the fourth part, px is equal to kx square minus 3x plus k. Since x minus 1 is the factor of px, therefore p of 1 should be equal to 0. P of 1 is equal to 0, implying k into 1 square minus 3 into 1 plus k is equal to 0, implying k into 1 square is k, minus 3 into 1 is minus 3, plus k is equal to 0.